It is 7:03, so we will begin now and people will continue to trickle in. Welcome everyone, good evening. I'm Sarah Walker, the Walden Woods Project's Education Director. Thank you so much for joining us for our event with George Wuerthner, Fire Suppression and Climate Change. For those that do not know the Walden Woods Project, we are a nonprofit based out of Lincoln, Massachusetts. We preserve the land, literature, and legacy of Henry David Thoreau to foster an ethic of environmental stewardship and social responsibility. Our organization was founded in 1990 by recording artist Don Henley, and this April we will celebrate 33 years. This event is also sponsored by Restore the North Woods. Restore is a nonprofit membership organization founded in 1992 by veteran conservationists and grassroots activists. They are grassroots-based, using advocacy, public education, and citizen activism to address the root causes of our ecological crisis. The mission of Restore the North Woods is to create new national parks, save natural forests, and protect endangered wildlife. And for some Zoom housekeeping quickly, you are only able to see the host and the panelists. You can use the chat function on the bottom of your screen if you're having tech difficulties, and I'll do my best to help. You can also use the chat to correspond with each other, the host and the panelists. And if you would like closed captioning, you can click the live transcript button at the bottom of the Zoom screen. There will be a Q&A during the last 20 minutes or so with George. So please enter any questions throughout in the Q&A box on the bottom of the Zoom screen, which is different than the chat box. But if you get confused, I'll move them over. So with that, I'll turn the program over to Michael Kellett, Executive Director of Restore, who will introduce tonight's speaker.
Thank you, Sarah. I'm pleased to introduce George Wuerthner. I've known him for, I think, since the late 1980s. So I've gotten to know how much he knows about these issues. And he's traveled around the West extensively to monitor and review large wildfires. He's really one of the preeminent authorities on wildfire in the US, and also on finding real solutions to address this issue. He's published 38 books, I think is the latest number, including 2 on wildfire ecology. One is Wildfire, A Century of Failed Forest Policy, which I think the cover is on his PowerPoint presentation there, and also Yellowstone, The Fires of Change. And he was living in the Yellowstone area during the Yellowstone fires in the late 1980s. So he actually spent a lot of time literally there watching and documenting. He's worked for a lot of federal agencies as a botanist, as a backcountry ranger, a river ranger. And in the process, and also in writing his books, he's visited every major Western National Park unit, and all of them in Alaska. He's visited every national forest in the West, and the majority of BLM lands, and more than 380 designated wilderness areas, which is a goodly chunk of them. But he also knows the East. He was born and raised in New Jersey, actually, and he lived for a number of years in Richmond, Vermont. Spent a lot of time in the White Mountain National Forest, called for a national park in Vermont's Northeast Kingdom, and he's been a longtime advocate for the Maine Woods National Park. So, but he also, in recent years, he worked as the Ecological Project Director for the Foundation for Deep Ecology and Tompkins Conservation, which you may have heard of because they were involved in creating major new national parks in South America. He's now the Executive Director of Public Lands Media, a nonprofit, and he's also the board chair of Restore the North Woods. So I'd like to introduce George to present on fire suppression and climate change. Take it away, George.
All right, thank you, Michael and Sarah. And this is the cover of one of the books that I've published a while back, but most of the information is still relevant today. What I'm going to tell you today, though, will seem counterintuitive. And I use this analogy that the sun rises in the east and sets in the west, and it circles the whole horizon. And so it would be natural to assume that the sun circles the earth. But of course, it's just not true. And a lot of things in fire ecology, as well as in the rest of science, is often counterintuitive in the same way. And much of what I say today, I think I can stand behind in 5 or 10 years, but I also have to modify as new information comes up and things, new nuances and so forth in the issues. So one of the things that I read all the time and hear about is this sort of dichotomy of good fire versus bad fire. And I want to point out that that is a pretty subjective, human-centric perspective. In terms of ecological situations, there's no such thing as a good fire, bad fire. The only bad fire I would say is when it burns down somebody's house or homes or causes death. But most wildfires are doing things from an evolutionary point of view. I'll talk about this in a minute. But keep in mind that climate weather, not fuels, drives large fires. And this is contrary to a lot of what you hear. You'll see people saying that the biggest problem is we have too much fuel. And I'm mostly talking about the Western US at this point, but I will have some references to the East in a little bit. But keep that in mind that fuel treatments are largely ineffective at precluding large blazes because these blazes are driven by climatic factors. So we have this bias in a lot of our understanding of fires because a lot of the research on wildfire ecology is done by foresters at forestry schools. And, you know, a lot of forestry schools get their money from the timber industry. So, you know, you just follow the money and you can see there are certain questions or assumptions that you won't use in your research because you won't get funding. And one thing that is really prevalent is this industrial forestry paradigm of thinning, logging, salvage logging is a cure for what ails the forests. And of course, they define that the forests are sick and need to be helped. But the result of their solutions is a simplified forest ecosystem that has few dead snags and down wood. And this picture I took was in a certified sustainable forestry site. I visited 7 or 8 of these sites around the country, including in the East. And most of them are similar. They get rid of the dead wood, they get rid of the snags and so forth, and they call it a sustainable forestry. But a sustainable forestry ecosystem is different than just having trees survive. It's all the things that depend on that forest ecosystem. And this kind of extensive logging does not maintain the ecosystem. A healthy ecosystem has a lot of what we call biological legacy. That is like dead trees, snags, down wood. This looks messy to a lot of people compared to the previous picture, but this is a much healthier site. The other thing to keep in mind, again, the bias that we have is forests do not recover from fire or from insects or whatever, because there are a whole lot of species that depend on the dead trees and the snags and the wood. So they actually live in fear of green forests. And this is sort of, again, contrary to the way we think about it. We think about green forests as being the ideal. Well, you know, that might be good if you're a timber company, but it's not necessarily ideal if you're, say, a woodpecker or a small vole that wants a place to hide, or fungi or whatever. And interestingly, the second highest biodiversity found in forest ecosystems after old growth forests are the snag forests that result from severe stand replacement fires. Again, this is not the way people think about fires. They think, oh, you'll hear all the time, the fire damaged or destroyed the forest ecosystem. In fact, as I mentioned, all these different species depend on dead and down woods. 45% of all bird species in the West depend on dead trees and down wood. And it's not just woodpeckers. Things like roosting for bald eagles, or the picture on the left is a bluebird that nests in a cavity. Bats in the West and in the East depend on the flaky bark on dead trees where they roost. So who thinks about bats being dependent on dead trees? Not most people don't. They've found that there's a higher bee density and diversity where there have been high severity fires. And that's partly because after fire, you get a lot of flowers and so forth, which of course the bees seek out the pollen for. And another surprise is fish habitat is improved. The more logs you have in the stream, the more fish. I've talked to any number of hydrologists and fish biologists, and they will tell you there is no level of fallen wood in a stream that is bad for fish. The more dead wood you have in the stream, the better for fish habitat. But we have all these factors you'll hear all the time responsible for an increase in large fires, such as fire suppression, lack of Indian burning, and so forth. But the driving force for all large wildfires is climate warming due to carbon emissions. So keep that in mind. What we're seeing now is largely a human-created situation. Nevertheless, most Western, this is primarily plant communities in the West, evolved with fire, and yet we have these pejorative language to describe them. The wildfire destroyed, damaged, etc. And yet it is one of the main factors that creates healthy forest ecosystems. And I want to give you a definition here. I don't know if, let me see if there it is. My marker goes, okay. So you hear these terms, low severity, mixed severity, and high severity fires. A low severity would be something like this, where you can't even tell the trees had any burn around them. A mixed severity might be something in between, like this and here, or like over here, where you get some trees that are killed and some that aren't. And then a high severity would be a patch like this, where most of the trees are killed. And in reality, most larger fires have a mix of all these things. And when you average them together, even in the biggest forest fires, where people say it was a high severity fire, are probably more mixed severity than anything, because you will have big patches of low severity or no burn combined with patches that are high severity. And what has really affected our thinking is this, what's called the Southwest Pine Model. And this says that fires were frequent and didn't kill the trees, and they were primarily referring to ponderosa pine, like you see here, and that most trees survive the fires. And therefore, the way a lot of people suggest, that's what the ideal is, and we should be trying to mimic that Southwest model. But it only applies to a very small percentage of forest types, and primarily ponderosa pine and some other dry forest types in the West. But most tree species and plant communities in the West tend to burn at mixed to high severity. In other words, where a good percentage of the trees are killed. And they have very long periods, what they call fire rotations, between major fires. So Pacific Northwest Douglas fir, like on the west side of the Cascades, might go 1,000 years without a fire. Most spruce fires are several hundred to 500 years. Aspen 100 to 150 years, and so forth. Juniper 400 to 600 years, and so on. So this idea that fire suppression has allowed fuels to build up doesn't apply to all these forest types, because we haven't been successfully suppressing fires, even if you assume we've been successful, for 300 years or 1,000 years. And so with that kind of a large margin, you can basically say that most plant communities haven't been affected by fire suppression at all. Now, the same thing applies to eastern deciduous forests, and part of the reason is they're moist in the summer, so they seldom burn. If most of you in the eastern U.S. know, when you hike in the summer, you're hiking through like a green tunnel, and that's because of all the vegetation. And green vegetation does not burn easily. And one study in northern Vermont that I read a number of years ago felt that the fire rotation there was about 1,000 years. And so, in other words, on average, you'd go 1,000 years before any large patch of these trees in northern Vermont would burn at all. So to suggest that fire suppression is having an effect in eastern forests, except for a few specialized forest types, is pretty much an exaggeration. Now, one of the things contributing to this has been and I keep hearing more and more about this, is that, well, Indians used to burn the landscape, and therefore, since they're not burning anymore and haven't for a while, we're getting more and more fuel accumulation. But the research out there, for the most part, shows that Indian burning was mostly localized. So one of the studies, and there are a number done in the Willamette Valley in Oregon, which probably had some of the highest Native American populations in the whole country because they had salmon to depend on, acorns, and lots of other food. The research there shows that most fires seem to have been fairly localized, and broad changes in fire activity seem to track large-scale variation in climate. In other words, yes, there were times when there was more fire, but it was usually attributed and correlated with the climate. Same thing, another study that was done in Yosemite Valley recently found that records indicate that climate changes influence burning at all spatial scales. In other words, not just locally in the Yosemite Valley, but across the whole western Sierra Nevada. And the Native American influences appear to have been localized scale. In other words, you could probably show right here in the Yosemite Valley that there might have been more fire than maybe would have happened naturally due to localized Indian burning, but it didn't affect most of the Sierra Nevada. And the same thing has been found in the East. David Foster, who's at Harvard, found no evidence of widespread human influence. They did a comparative study and looked at using pollen and charcoal, which is a very good way to test this idea of whether Indians manipulated the landscape on a regional scale. And they found that the period of highest Native American populations of the last 14,000 years, there is no pollen or charcoal evidence for regionally extensive human impacts or open land vegetation. In other words, yeah, right around their villages, you could show that there was an impact, but it didn't apply to most of the region at all. And the conclusion was subsistence practices such as hunting, fishing, plant gathering, small scale farming, and remember, small scale, most Indian farms were just several acres in size, apparently resulted in local ecological impacts without transforming the broader forested landscape. So this has been found all the way across North America, and there's very little evidence for widespread manipulation by Native American people in North America. Now, down into Central America and so forth, yes, there's some evidence of widespread logging, basically timber cutting for cultivation and Mayan areas and so forth. But if we're talking about North America, there's not much there to go on except in a localized situation. I want to make you aware of another thing, that is problems with fire scar studies. Almost all the studies that suggest that fires were frequent, etc., depend on fire scars. And this is a picture of a fire scar. And what you do is every time a fire comes through, and if it doesn't kill the tree responds by healing and leaving a scar. And so what scientists do is they cut the tree down, they cut the rings, the growth rings in between each scar, and they can come up with, over a period of 100 years, the average fire interval is, say, every 10 years or whatever. But even in this fire scar study, there was one interval that was 64 years. So to suggest that these fires burned every 10 years, it gives this impression it's like clockwork when it's not. It's very variable, and you could have two fire years in a row and then not have a fire for 50 years. So to suggest that fire was real frequent may exaggerate the fire rotation in that area. And the third part is they use composite fire scars, which tends to reduce the years between fires. And I know this is going fast, and I just want to make you aware that fire scar studies have problems. The other thing is that the idea that because some people say we had fires very frequently, that the forests are out of the historic condition, ignores the fact that most of the plant communities out there, as I mentioned earlier, have longer fire rotations, often of many hundreds of years. And basically what that suggests is that most of these forests are actually within historic conditions if you have a long enough temporal scale to evaluate them from. In other words, if you look back 500 or 1,000 years. And the other thing we see today a lot of is what I call shifting baseline. And the shifting baseline is, you hear all the time, well, since 1970, we're seeing larger and larger fires. And that's absolutely true. But It ignores the fact that before the 1970s, we had even larger amounts of fires on the landscape than we have today. But if you ignore that, you can get away with saying that, oh, well, we're now having larger fires. And if you look at the condition, this chart shows here, back in the 1920s and 30s and 40s here, there was a Pacific decadal oscillation where there was ocean currents that influenced the fire frequency on the landscape because it created warmer conditions and drought. We had massive wildfires. In fact, in the 1920s, there were times when as much as 50 million acres burned in a single season. And today we say, oh, 10 million acres burned and it was a record. Now, the other thing to keep in mind is starting in the 1940s through all the way into the 1980s, it was a cooler and moister period of time. When I was a young person, I was hearing all these reports that we were entering an ice age because it was so cool and moist. Well, when it's cool and moist, you don't get many fires. And then since that time, it's gotten warmer again, mostly due to human carbon in the atmosphere, climate warming. But nevertheless, we can tell that if you have warm weather conditions and climate conditions, you'll get more fires. So back in the 1970s, glaciers were growing in places like the Pacific Northwest. So not surprisingly, fire suppression was successful. And I put that in quotes because it was really the cool, moist climate that suppressed fires. And if we take a longer look, we'll find that there was a thing called the medieval warm spell. And that period was basically from 800 AD to about 1300 AD. And in this time period here, it was warmer than more recently, particularly in between here, between about 1400 and 1850 was the Little Ice Age. So it was cool and moist through that time. So when they do fire scar studies and they go back, say, 200 years or something, they're looking at what the fire history was at a time when it was cool and moist. If we go back further in time, we find that there was many large wildfires during that medieval warm spell. And this was a time when the Anasazis abandoned their cliff dwellings in places like the Southwest. And it's also when the Vikings colonized Greenland. And Greenland was greener then because it was warmer. So if fuels drove wildfires, we would expect the largest fires in places like the Oregon Coast Range, because that's where you got more fuel than any place else. But it's really lush and green. It's cool and moist next to the ocean. It almost never burns. It's usually hundreds to almost maybe 1,000 years between any significant fires. And the other point to keep in mind is that most fires are small, no matter what, and they go out without suppression. They did an experiment in Yellowstone where between 1972 and 1987, there were 235 fires in the Yellowstone backcountry, and they decided not to do any suppression. And out of those fires, 222 burned 5 acres or less, and only one burned more than 1,000 acres, and all went out without suppression. And the point of that is, unless you have the right climatic conditions, fires just self-extinguish. We don't need to even be putting them out. They'll go out on their own. And the majority of fires fit in this paradigm. So for example, this is from the Rocky Mountains. There were a total of 56,320 fires between 1980 and 2003. 98 of these fires accounted for only 4% of the area burned. In other words, you had just tens of thousands of fires that most of them burned 5 acres or less, just like in Yellowstone. And then of the fires that burned more than that, it was 0.1% of all blazes were responsible for half of the acreage burned. So again, it's these few fires burning under extreme fire weather conditions that account for almost all the acreage burned in any one year. And why is that important? It is important because we're trying, our fire policies are designed to stop these particular fires when they're basically unstoppable. And they are a very small percentage of fires. So I make this comparison with earthquakes in California. Each year in Southern California, there are 10,000 earthquakes. Most of them are so small, nobody feels them. Several hundred only several hundred are greater than 3.0 on the Richter scale, and only 15 or 20 are greater than 4.0. And it's only the ones that are like 6 or 7 on the Richter scale that do any damage. And it's the same thing with large fires. Most of them are so small that they're not even noticeable. The other thing about the solution, that fuels are the problem, and they want to log and do prescribed burning to influence that, is most fuel reductions don't ever encounter a fire. In other words, the fires never happen. So this graph this is all the forests in the West, 350 million acres, and this little yellow dot right down here is the amount of forests that actually encounter a fire in any one year. So you're doing this treatment across the forest where most of them will never encounter a fire at all in any time scale that's important. So when do you get the high severity fires? They are when the humidity is low, and high temperatures and extreme drought and wind, and then you get unstoppable fires. And the biggest factor of all large fires is winds. A recent study found that 90% of acreage burned occurred during periods of high wind. And, cutting the trees down doesn't do anything to prevent winds. In fact, it actually enhances the spread of fire because it makes it easier for the wind to get through the trees when there's fewer trees blocking the wind. And what you see is when you have high winds, you get all these sparks being blown. And this is what happens. You get new fires. They're called spot fires in front of the next fire. So extreme winds are the main factor in large fires. And one thing to keep in mind is wind as effect is not linear, it's exponential. So if you have a wind blowing at, this is a graph showing how many minutes it takes to cover miles here. If you've got a 15 mile per hour wind versus a 20 mile per hour wind. Now imagine what this line looks like if you were suddenly had 80 mile per hour wind. This line would be the hockey stick thing, straight up. And that's when we have these large fires, when there's winds blowing 50, 60, 70, even sometimes 100 miles per hour. And this is what you get, spotting. This is in Yellowstone. This is Yellowstone Lake out here in 1988. But all these spots out here are where fire got wind blown and started a new fire. And this is why they're so difficult to fight, because you can put a bulldozer line in here. You can have a road in here. It doesn't matter. You can have a thin forest in here, and the wind will blow the sparks across and over and around any of the fire fuel treatments you have. So I'm getting a problem here. Just a second, please. Just a second. I don't want my screen to go blank here. See if this works better. Yep, okay. The other reason is that has to do with fire policy. Fuel reductions like prescribed burns may influence fires that are burning under low to moderate fire weather, but prescribed burning affects so little landscape as to be unimportant. It's like using a watering can and calling it a river. And evidence abounds that forest management of any kind, whether it's logging, fires, prescribed fires, etc., do not significantly alter fire spread under extreme fire weather. So you can see all these clear cuts out here, and the fire just burned all around the clear cuts. Here's a place that was thinned 6 months before outside of Helena, Montana. They turned it into a savanna, and you can tell that these were logged because the tops of them are black where the fire came through, and it didn't affect the fire spread at all. So, and interestingly, research shows that actually on high severity fires on private industrial lands were 1.8 times greater than on public lands. And the reason is because the industrial forestry leaves around a lot of debris like this, that it's the fine fuels that burn in a fire. And they also open up the forest so that winds can blow these sparks across great distances. So this is an example. In 2020, there was a big fire on the west slope of the Cascades called the Holiday Farm Fire. And you can see this blue line right here, that's a reservoir. And the colors here indicate the fire severity. So red was high severity, yellow was mixed severity, and green is basically no fire at all. But you can see that there was a fair amount of high severity here and a lot of mixed severity. Now, this is what here's the same reservoir right here. This is industrial forestry land. As you can see, there's a lot of logging there, a lot of clear cuts and past clear cuts, and it did nothing to stop the fires. And in fact, the biggest patch of green is right here, which is this section right up here where there was almost no logging. So I've seen this in many, many places. This is the Dixie Fire, which burned 900,000 acres in California in 2021. I just happened to take these photos in May of 2021 of a thin forest. And I went back in the fall after the Dixie Fire to the same place, and you can see the stumps from previous thinning. And as close as I could figure out, this was the same general area. And there's a clear cut in the background right here, same back over here. And you can see that that had no effect on the fire. Another fire I visited was Thomas Fire near Santa Barbara. And all this is burnt chaparral down here. You can see the burnt trees here. And the only thing that stopped this fire was the Pacific Ocean. That was a fire break that worked. But anything short of that, you know, a 6-lane highway, all sorts of fuel treatments, nothing stopped that fire. And here's another example. The Eagle Creek Fire, which was near in the Columbia Gorge near Portland. You can see where it burned here. It jumped the Columbia River, which was 1.5 miles wide. I mean, there's no fuel break better than that. There's no fuel at all. And yet it didn't stop it. It jumped the Columbia River and started fires on the Washington side of the river. So the majority of acreage burned by wildfire occurs in very few fires under extreme conditions. Under these extreme conditions, suppression efforts are largely ineffective. This is research from the fire lab in Missoula. Other papers come out to the same conclusion. Extreme environmental conditions overwhelm most fuel treatments. Another review concludes fuel treatments can't stop big fires, cannot realistically be expected to eliminate large areas burned in severe fire weather. By the way, this area here had been thin prior to this fire. You can see how well that worked. The Congressional Research Service looked into it, and they found that a very weak relationship between acres logged and the extent and severity of forest fires, and that fewer acres burned in areas where logging activity was limited. Another study in 2016 found that they looked at 1,500 fires. So this is a review paper. It's not, you can always go to some fire and say, oh, look at the thinning, changed the course of this fire, or prescribed burning changed it. Of course, we don't know whether, you know, the temperature suddenly went down then or it rained. You got to know the local situation at that time. But put that aside, when you look at 1,500 fires, you can come to some conclusions. And they found that forests with higher levels of protection, in other words, like parks or wilderness areas, had lower severity values fires than those that were, even though they had presumably the most biomass because they'd never been logged. And this is why in August of 2018, scientists, over 200 scientists, sent a letter saying thinning is the most often proposed method to reduce fire risk and lower fire intensity. However, as climate changes, most of our fires will occur during extreme fire weather, high winds and temperatures, low humidity, low vegetation more. These fires, like the ones burning in the West this summer, will affect large landscapes regardless of thinning, and in some cases burn hundreds of thousands of acres in just a few days. And one of the reasons for this, and this again counterintuitive, is that live trees actually burn better than dead trees under extreme fire weather conditions. And the reason is because they have more fine fuels. Fine fuels is what burns in a fire. So the needles, the branches, and so forth. And these needles and so forth have resins in them that are highly flammable. Whereas a dead tree, a snag, especially once the branches sort of fall off, is pretty resistant to any fire. Trees don't burn, which is why you get the snags left after a forest fire. So this is what's crazy about thinning. We go in and we cut out the big trees like this, saying we're going to stop fires when the big trees aren't what burn. So we sanitize the forest. This is on the Deschutes National Forest in Oregon. And it's, to me, is a degraded site. There's no down logs. There's no snags. The trees are all about the same size. They're saying that this is a healthy forest ecosystem. To me, this is a very degraded forest ecosystem. Another factor that's not considered is that logging removes a lot of the carbon from the forest, a lot more than a fire. So this chart shows one study area where the amount of carbon that was stored in an old-growth forest after the fire, you still have most of it left, but after logging, a good percentage of it was taken away. And in fact, in Oregon, logging contributes more emissions than wildfires. In fact, more than anything else in the whole state. 35% of the carbon emissions in the state of Oregon come from logging. That's more than transportation, more than industry, etc. And of course, wildfires are a small percentage too, 4% compared to 35%. So fuel reductions are inefficient and ineffective. And the way to protect communities and homes is to reduce the home ignition status on private lands. And that's the way to protect people's homes, is start with the home outward. Because what happens is sparks, as I showed before, with the wind can blow a couple of miles in front of the fire front. And if they land on a home that's vulnerable, it will burn to the ground, and it'll often burn its neighbors to the ground, because houses have put out more heat per minute area than a forest fire. So these houses are close together, and they didn't get a spark on them, but this whole little neighborhood burned down from that. And this is the campfire that burned Paradise, where 19,000 homes were destroyed and 87 people were killed. Notice these foundations here, and there's green trees all around. I mean, some dead trees, but a lot of green trees, showing that what happened is sparks hit these houses, and some of them were vulnerable, and they burned the whole neighborhood down. And to just show you how campfire affected, this is the area right outside of the campfire. There's clear cuts all over. There were hazardous fuel reductions. There were even some previous fires. If you were going to pick a spot that should be protected from fires because of fuel reductions, this is the poster child. But it didn't work because you had high winds blowing during a drought. So it's the treatment of fuels immediate proximate to the residents and to the degree which the residential structures themselves can ignite that determines if the residences are vulnerable. So you can see houses here in the background that didn't burn down. I don't know why they didn't and why this one did, but it's obvious that some are more vulnerable than others. So another thing to consider is you don't have to log very far or thin very far away from a house, because intense flame fronts will not ignite wooden walls at distances greater than 130 feet away. And you can have intense flame as close as 30 feet away. And if your house is properly treated, it will survive the fire. Now, this house here, you got pine needles on the roof, you got trees right next to you, you got these shrubs right next to the walls. This is not a good situation if you want to keep your house from burning down. So ultimately, we must reduce the greenhouse gas emissions in the atmosphere. Climate warming is exacerbating fire spread and size. Climate weather drives large fires. Fuel reductions have limited value. Yet Congress just allotted $930 million to mostly do thinning projects and prescribe burning under the illusion that they're going to protect communities, and we're not doing anything to reverse climate warming. Worse, these are expensive and delusional. The probability of any large fire to counter a fuel treatment is really low. So most of this money we're going to spend is going to be wasted. We're going to cut down the forest. We're going to do prescribed burning, and the chances that an actual fire will encounter is less than 1%. And the other thing to remember is wildfires and other natural events like bark beetles improve and invigorate ecosystems. They're natural evolutionary factors. And this is the other thing with doing thinning. A forester out there or a logger with a chainsaw has no idea what kind of genetic resistance any particular tree has. So, and trees vary. Some trees are more resistant to bark beetles. Some of them are more resistant to wildfires or disease. And you go in there and you cut those trees down, you're actually diminishing the resilience of that forest ecosystem. Whereas if you let natural factors do the selection, for example, let's say a drought, well, the trees that are better adapted to a drought, or at least in a better spot to withstand a drought, are the ones that will survive. And the ones that don't, well, they're a good thing to get them out of the ecosystem because we're getting more drought. And the other thing to keep in mind is that large wildfires and beetles provide the bulk of dead tree recruitment in forest ecosystems, and dead trees and down wood are critical to healthy forest ecosystems. And the way to protect communities is to reduce home flammability and zoning to prevent building in the fire plain. And then finally, we need fires to create habitat for forest elves and a lot of other species. And so we don't want to totally eliminate them from the forest, or we will lose these species like little elves. And that's the end of my talk. Thank you.
Thank you so much, George. And ending on a good note, I like that. Lots of great information here. Just for people at home, this is being recorded and it will be on our website and YouTube in about a day or two. So if you want to go back and watch, like I'll be doing, you can do that. So we'll go ahead and get started on the questions. Again, you can enter them in the chat or the Q&A box. We have a few ready to go, so I'll just jump in and read them to you, George. First question, if climate change drives fires and fires are good for ecology, then is there a problem? Fires that are a result of climate change are okay, question mark.
What I would say is that the wildfires are helping the ecosystem adapt to climate change. In other words, that and things like drought and beetles and so forth are selecting the species and individuals who are best adapted to the current conditions. And so I wouldn't say that, again, trying to say one thing is a benefit or not is really not what I'm trying to say. I'm trying to say that we have climate warming, and climate warming means that that's going to have an influence on the forest, and the forest will adapt through factors like wildfire. So in a way, you could say that the wildfires are helping the forest adapt to the climate realities of today. And if they change, if we somehow were to reduce climate warming, or suddenly a major volcano would go off, or a meteorite hit the earth and we got a lot of dust in the atmosphere and it cooled suddenly, I can guarantee you we wouldn't have large fires then. So.
Next question, how can we end logging of public lands?
Well, here's an interesting statistic I just looked up a week ago. So this is the Congressional Research Service did a study, I think it was last year, and found that only 2% of all the wood products in the United States come off of national forest lands and other public lands, BLM, mostly Forest Service. So you're talking about a very small percentage of the wood products in this country originate on public lands. And you could make the argument, which I would, that these forests have a higher value for all sorts of other things, like carbon storage, for example. Right now, we need to store as much carbon as we can. And as I pointed out, logging the forest releases a lot of carbon. So the better use of these forests, in a sense, from Gifford Pinchot said that we should have the best use for the most people. If you were going to use that kind of subjective kind of criteria, it's easy to argue that no logging is better. It's also better for watersheds, it's better for soils, it's better for wildlife habitat, recreation, and so forth. So the idea that we need to, and I put it in quotes, need, there is no need to log national forest lands, and we could say that they have a much higher use for all these other values than for wood. We just don't need it, and we could easily reduce the amount of wood that we use as a country through what we use for building materials and greater recycling and other factors that would totally absorb it, that 1 to 2% that perhaps come off of the national forest.
You said that fire is self-extinguished. That is a great relief to hear, because I'm very concerned about what the chemicals being used to fight fires are toxic to the air, to the water, to the soil, to the remaining trees, and to the wildlife in its way. Is there any effort to get the use of these toxic chemicals stopped from being used? Am I correct that these chemicals are toxic to these parts of the ecosystem?
Yes, you are correct. I'm not an expert on this, but I do know that there are a number of groups that are suing the Forest Service over the use of its flame retardants that they dump on wildfires. And the reason they're doing that is because they say that they're detrimental to the ecosystem and harm it. that's not something that's within my expertise, so I'm not going to comment further, other than to say that some people share that same concern.
Mhm. Next question. I'm sure that fire will soon be used as a blanket excuse to do more logging in the East. What do you think is the simplest argument to prevent that from spreading?
Well, for one, is that fire is just pretty uncommon in the East, even in climate change right now. You just don't get large fires there very often until you have really extreme conditions. And because the Eastern United States is characterized by, you have moisture all through the summer in most cases. You have a lot of green vegetation. Green vegetation takes longer to ignite than dried out vegetation. And so the chances of large scale fires in the East are pretty rare. They've happened in the past. There, in 1903, there were some huge fires across the Adirondacks and other places in the East. One of the biggest fires in the United States happened up in Michigan or Minnesota or Wisconsin, somewhere in the upper Midwest. So it can happen, but it's not a very common feature of the landscape. For the most part, fire is less important in Eastern ecosystems, except for specialized landscapes. The Southeast, for example, has piney woods where fire is fairly common experience because they get a lot of lightning. Florida gets more lightning than any place else in the U.S. So places like that tend to have more frequent fires. But if we're talking about New England, for example, the upper Midwest, fire is pretty rare in those ecosystems.
And people build in floodplains and expect federal insurance to help them when the inevitable occurs. Is the situation similar for wildfires?
You bet it is, and that's part of the problem. Is I have mixed feelings. I feel sorry for people whose homes have burned down. At the same time, allowing them to rebuild in an area that's extremely fire prone is foolish. Now, in some cases with floods, I don't know what the exact criteria are, but I do know in some cases they say you can't build back in the flood. We'll give you money to rebuild, but you have to go to a different location that's not vulnerable to floods to rebuild. And we could certainly do that in the West as well. And in fact, it's also happening indirectly because of insurance companies. In parts of California now, it's becoming difficult to get fire insurance on your home. And if you can't get fire insurance, you can't sell your house, you can't buy the house. And so of course, just like hurricane stuff in the East Coast, the government's going to come in and be the insurer of last resort. I don't know what terms they're going to make on the insurance, but that is having an effect. But the real problem is that just like floodplains, we can predict to a degree what places are more vulnerable to fire than others, and perhaps not allow at least new construction in those areas. But of course, that goes against the whole American tradition of it's my property, I should be allowed to do whatever I want with it, blah, blah, blah. So, maybe the way to do it is to have, if you're going to build in those places, put in the maximum kinds of things on the requirements on the home that will reduce the flammability. For example, aluminum or metal roof will reduce the chance of your house burning by a very significant amount. Some studies say over 90%. Having double pane, triple pane windows reduces fire entry. Putting screens on any vents reduces fires. So there are a lot of things you can do, but sometimes you have to think out of the box. I read one study down in California where they looked at 50 houses that burned down and found that the majority of houses burned down because of doggy doors. And you may say, why is that? Well, that's because you remember extreme fire is when there's high winds, and doggy doors are made to open up with not a lot of resistance. So what happened was the high winds were blowing and they blew sparks inside the houses, and the houses burned down from the inside. So, but anyway, the point is there are ways to construct a home so it's resistant. And if you had that being mandatory in communities or new construction, it can reduce the amount of damage. In fact, California introduced some new restrictions or regulations related to construction. I think it was in the 1980s or something. And like in the Camp Fire that burned they showed that a significant amount of the houses that survived had the new regulations in place. So they do work to a degree.
Mm-hmm. And this answer, or your answer for the next question, might loop back into a previous answer, but just in case not, do we have data about fires in eastern forests where there are few pines?
Yeah, there's some studies, and not as nearly as much as in the West, because fires are just not as common in the East. So there haven't been the studies like you find all over the West. But the studies that I have seen, like I said, depending on, all this depends also on the type of vegetation that's growing there. But let's say northern hardwood forest with sugar maple and beech trees and things like that you would have in, say, Vermont and maybe Massachusetts and places like that. They don't have fires very frequently because of the reasons that I said. They tend to be moist in the summer. They at the time, and the reason that's important, because the summer is when you get the most lightning. But because they're moist, the lightning doesn't ignite fires very frequently, and when they do ignite, they don't burn very well. So that's why.
Mm-hmm. And are there any studies underway to document the amount of carbon contributing to climate change from thinning and other treatments?
Yeah, there are a number of studies that have been done in the West on that. I didn't include them, but yes, those studies exist. And they show that thinning and cutting the trees contributes a lot to carbon. And one of the things, here's a little alert about how these studies are done. Studies, you got to be careful and look at them carefully. Like one of the sort of tricks, I don't think it's done on purpose. I just think that the people doing the studies haven't thought about this, but they'll go in and they'll thin the forest, and then they'll say, well, we had a lower tree mortality after a fire came through than before thinning, but they don't count the mortality from all the trees they cut down with a chainsaw, and all the carbon that was removed when you cut them down and took them out of the forest. And if you included those trees in with the area that burned, you would find that there was actually more carbon released because the logging combined with fire than if you had not done the logging to begin with.
And speaking of studies, someone asked, is there a bibliography for this talk? I'd love to dig deeper. If you do have resources, George, you could always email them to me and I can put them up on our website along with your talk. But I'll let you answer to that first.
Well, what I could say is I have a fair number of articles that I've written on a thing called the Wildlife News. And if you put in my name, Wuerthner, Wildlife News and Fire, or Wildfire, it'll pull up a lot of these commentaries. And I usually have, through my commentaries, at least in more recent years, links to studies and statistics and so forth. So if you were to bring those up, that would then be a way to find more studies that I've talked about that I use in this talk as well as other talks.
And have you heard about the move to designate the Shawnee National Forest as a climate preserve?
I have heard about that.
Okay.
Yeah, no, I have. And of course, there have been some studies that have looked at the which national forests in the West have the most carbon, and they tend to be Pacific coastal forests like the Willamette Forest in Oregon, the Gifford-Pinchot Forest in Washington, the Tongass Forest in Alaska. And those forests have huge amounts of carbon. And if you were going to make the argument that any forest should not be logged, those would be the ones that you could make the best argument for if you were just talking about carbon storage. Unfortunately, they also tend to be the ones that are the most logged. So like the Willamette National Forest is the #1 wood producing forest in the country, and it's also got the highest percentage of carbon in the forest.
A nice juicy question. Our National Park Service is doing best as federal agency in coming closest to your suggestions. How can NPS improve management, or do they need to make any changes?
Yes, I think on the whole, national parks, I'm very much in favor of them because their general mission is to protect functioning ecosystems, which is not necessarily, well, I shouldn't say, the BLM and the Forest Service are supposed to do that as well, but they have conflicting mandates to, for example, log the forest or graze the land and so forth. So the mission of the National Park Service is the most preservation oriented agency, and the people that work there tend to be the most preservation oriented federal employees. Notwithstanding that, there have been some recent moves in some national parks to do some logging and thinning, presumably for the same reasons that the Forest Service does, to supposedly reduce the vulnerability to fire. I just was in Yosemite a couple of months ago, and there's some logging going on in the Yosemite Valley right now, pretty much like small clear cuts there, and that's being driven by some of the agency folks there that are, there's a shell shock thing that's happening, particularly because things like Yosemite and Sequoia have these sequoia trees, which are very large trees that have survived thousands of years, like the ending slide I have in here in my show. And so a number of years ago, there were some large fires, particularly in the southern Sierra, that killed quite a number of sequoia trees. And this has got people worried that, oh, we're going to have no sequoias left. And my response to that is that very likely the sequoias depend on fire actually to get established. And I mentioned the medieval warm spell in 800 to 1300 AD. Well, a lot of the big sequoias that we have today originated from that time. One presumes there were probably some large fires that killed sequoias back then too, but it also created the right kind of habitat for new generation of sequoia trees to become established. So I'm less concerned about that than some, but we're just all talking about the future, and who can guess. I would, there are small things you can do to reduce the chances of a giant sequoia, dying from a fire, which the Park Service is doing. Some prescribed burning right around, and some thinning right around some of the bigger trees. Maybe that's okay. It's not a park-wide policy, and it's not something that's being done across the whole landscape. And I might be willing to concede we could do that in a few places and see how it works out. On the other hand, in general, any of these things, unless they're strategic and specific, don't work. So you have to say, is it worthwhile trying to do this across a whole national park? And I would say probably not.
All right, so we have 2 more questions. I think we can get through them quickly. What can we do to reverse the trend to fund logging and prescribe fires in the name of fuel reduction?
Well, that's why I'm giving you a talk, because it takes people all across the United States to write to congressional delegations and, question the wisdom of these policies. The evidence is out there. If you go, I've gone to dozens of large fires, and almost all of them have had fuel treatments in them, and they haven't affected the fires under the extreme climate conditions. And so it's sort of like, come on, folks, start looking around and see that that these kinds of things don't really work very well under those conditions. And then what happens is they work perhaps under low or moderate fire conditions, but as I said, most of those fires will probably go out on their own anyway through self-extinguish. So we come in and we show that the fire burning under a low fire condition runs into a thin forest and drops to the ground and doesn't burn much. I say big deal, because that fire wasn't going to burn very far anyway under those conditions without the wind, etc. And so you sort of get this false narrative that, oh, thinning or prescribed burning is working to stop these fires, and it's just almost laughable. If you've ever been around, I've got this video that was taken in 1988 during the Yellowstone fires. I mean, the trees are whipping back and forth. I mean, like this far in the winds that are blowing 80 miles an hour. And if you think that that's, some little trench that a firefighter has built a foot wide is going to stop a fire, or even a bulldozer line or a road or anything like that, you're just delusional. And
Mm-hmm.
so we have to look at the exact situation. And the other thing I will point out is be careful about. Some people will claim, oh, thinning worked under this condition and so forth. But you have to know exactly what's happening hour by hour, because I have in other slideshows, I would show you a graph of a fire that burned in Colorado, where I have the hour by hour humidity, wind, etc. And what you find is when the fire started, the wind was blowing 44 miles an hour and the humidity was down to 4%. And then apparently the fire was contained by slurry bombers and firefighting, except that the humidity was at 100%, which meant it was raining. So, and so, you know, they'll take credit for putting out the fire when the fire was going to go out anyway, probably without any slurry bombers or any of that other stuff. But we put on the air show to convince people that we're doing something.
All right, last question, I think will be an easy answer. Do down logs in New England forests hold moisture?
Oh, yes, that's another good point. That's another good point. The down logs soak up a lot of moisture, and they're like natural fire breaks. And they take a lot longer to dry out. And again, the bigger the log, which is why you want to have more and more large old growth trees, the bigger the log, the longer it takes to dry out. So every one of those logs that are wet in the forest floor is like a little fire break, and a fire gets to it, and it will often go out, or it can't, you know, grow over or around that log, and it won't burn up the log because it's too wet to burn. So yes, those are natural fire breaks that are found throughout the forest.
All right, I want to be mindful of your and Michael's time, so we'll wrap it up there. Thank you all so much for joining us, and thank you, George and Michael, who made it happen. And lastly, the Walden Woods Project and Restore the North Woods have been doing our virtual lectures and events for free. We continue to do so. If anyone wants or can make a donation to either or both of our organizations, feel free to do that, and we will be very grateful. I'll post the links to our organization's donation campaigns in the chat. And the Walden Woods Project has a few virtual events coming up in the next few months. That's part of the On Belonging and Outdoor Spaces speaker series, hosted alongside other Lincoln conservation organizations. So be sure to check those out at walden.org. If you have any event to plug on Restore's side, Michael, feel free to mention that. But if not, thank you both, and thank you everyone at home for joining us.
Thank you.
Thank you.
Good night, everyone.